and share my screen. All right. Hopefully you can see my screen now, the whole thing. All right. So today's lecture is going to be mostly about object-oriented programming, and at the end we will cover some exception handling warnings and such. And we will also talk about a new feature in Python 3.10. But let's start with the beginning, which are the definitions of classes, instances. So if you know C++, Java, C#, or any object-oriented language, you are familiar with the class as a word used in programming. It's good for bundling pure data and functions that should belong together, and an instance is an instance of this class. So when you create a new object with that type, then it's an instance. All right. How do we define classes in Python? Well, we use the class keyword, obviously, and we usually don't overwrite the constructor for Python, because the constructor is new, like in many other languages, but we usually only overwrite init. Python in the background, when you create an instance of a class, calls the new function, which creates the object, and then it calls the init function, which initializes the inner state of that given instance. And we usually only want to mess with the initialization part. You can create a class with an init or without one, and it should run the same way in this case. So there won't be any kind of errors if you don't define an init function. And in this case, this init function doesn't really do anything. Classes and instances can have attributes, and these attributes can be defined within init and outside of init. And actually, it's correct to define it outside of it. But if you don't call the method function on an instance, then you can't access attribute 2 because it hasn't been defined. And if we jump over to PyCharm, if you try to do the same thing in PyCharm, it will actually warn you about this thing. It's correct. It won't cause any problems, but it will give you a warning. Visual Studio, on the other hand, doesn't do this. It just accepts that you defined your new attribute there. All right, let's see what's the output for this. And if I try to access attribute 2 before method is called, then we should get an attribute error. And we do, because it's not live yet. Also, you can add new attributes to an instance outside of the class definition itself. But this attribute will be only accessible for that instance. So you create the attribute only for that given instance that you defined it for. If we check this, you can see it raises an attribute error because attribute 3 is only defined for object A. And you can access the attributes and methods, the names of those of a given instance using this property, dict. We will talk about these special things a bit later, but it will write out in a dictionary format the attributes of a given instance. And you can see that since A2 didn't have its method called yet, it only contains attribute 1, but if we call method, it already has attribute 2 as well. And everything is public by default in Python. So you can change every kind of attribute outside of the class definition as well. If you want to protect certain attributes, you can do that with name mangling, which is putting underscores at the beginning of the name. If you put 1 underscore at the beginning of the name, then it will be, you should treat it as private, but it won't actually be private. If you add 2 underscores at the beginning, it will be considered private, and it will raise an attribute error if you try to access it outside of the class definition. You need to, you have to keep the number of underscores after the word at the maximum of 1. So if you would write this, this wouldn't be a private attribute anymore. And we can see that if we try to access and modify the so-called private one, we can do that because it's not actually private. But if we would try to do something similar with the actually private attribute, it shall raise an error. All right, so why don't we add more than 1 underscore at the end of private attributes? Because that's a special thing. Python's special thing. Those are the double underscore or thunder notation attributes, such as dict, which we have looked at before. You will see the classes, attributes, and functions, or the instances, attributes, and functions, if we would have any kind of functions. And you can actually, there is a list of these special attributes in the documentation of Python. And some of them are writable. And you can see those somewhere here. Yeah. This is the collection of these special attributes, and you can see if those are writable or not. These documentations are linked at the end of this notebook. All right, so we have seen instance level attributes so far, but we can also define class attributes like this. And those are accessible via the instances as well, but they can be accessed via a non-initialized class as well. And if we would change the attribute on a class level, so we don't access it via the instance and change it that way, but we access it via the class itself and use it to change the value of this class attribute, that will change the attributes of the instances as well. But if we would try to change it via the instance, the instance's value will change, but the class value itself won't. And you can see that it's because the new attribute has a copied class attribute. And that's actually the thing that changed, and not the class attribute, the original class attribute itself. We can see the classes attributes, the original attributes. All right. Any questions about the attributes of classes or instances? All right. Then let's go on to the methods. Methods are the functions defined inside the classes. We have seen an example for that at the beginning of the lecture. And the first parameter of a method inside a class should be self. This is a naming convention. It can be called anything else, but it's more readable if you use the naming convention. And using self, the instance's inner state can be accessed. So, like you've seen previously, like here, we access the inner variables or the inner attributes of the instance using self dot the name of the attribute. And you can access these and the other methods defined on that class using self dot and the name of the method or attribute. This is actually like the this keyword in Java, JavaScript, and so on. There are two ways to call a method on a certain instance. You can instantialize, so you can create a new instance of a class and call the function on this instance. Or you can call it via the class, but you need to pass the instance to it as the first parameter. If you would try to do something like simply a.foo, even if foo doesn't need any other parameters, it does need an instance of the class. And you will get a type error if you try to do it without that. Are there any questions in the chat, maybe?
No, but I have one. with the function bar, there is parameters any. What does it mean? I don't think it was covered.
Oh, sorry. So as any function in Python, you can have parameters passed to it, and any is just the type hint covered in yesterday's lecture. So this part only means that you need to pass a parameter to bar, but this parameter can be any type.
Okay, thanks.
Problem. Oh, and this is the old type of formatting of the string. We can make it a bit more consistent with the other formattings in the file and replace it with the f-string version.
Sorry, I have a question.
Yeah.
For the calling methods, so in C++, it's a static function, right? If you can call it from the class itself. Is it in Python that you can do it with every class function, or do you have to somehow specially define them?
You can do this with every function, every method inside a class that does not have special class decorators like static method or class method, which is actually the next part in this lecture.
Okay. Thanks.
No problem. But it's important that you pass the instance to these functions if you try to access them via the original class. Now, let's see examples where you don't have to pass an instance when you call a method. One of these is called static method, and it is usually used if you don't actually want to access anything inside the class. So you just want to call it on a class level. It won't change anything inside the self or the class. And you can access it via an instance, you can access it via an uninitialized class. And let me show you some example in PyCharm. So if I were to try to define a new function, like function 2, it will fill in the self by default, but if I just say print something, then it will warn me that this may be static because we don't use the self parameter for anything. So if you are using PyCharm, you will get some notifications for best practices in this case. All right, so there is static method if you don't want to access self, but what about instances when you want to access class specific things, but not instance specific things? Then you use a class method, the class method decorator. We will talk about decorators in tomorrow's lecture. Just know that they are kind of changing how certain functions or classes work. Inside of them, they added functionality to those. They are like a wrapper. So if you want to define a class method, it's usually because you want to write some kind of factory. And this specific class method here will take a string and initialize a complex using the string representation of a complex number. And it can access the inner state of the class, not the inner state of an instance, but the class. And using this, we can initialize a new object. And don't have to worry about the instance. That's the basic difference between a static method and a class method. And the last...
sorry, Kinga, just
yeah.
There was one question in the Slack channel that could you zoom in a little more in the notebook so it is more visible and in the content? Yeah, like that.
Is it okay now?
I guess it is. Yes, thank you.
All right. Just should we go back a bit so you can see better? These are all on the GitHub already, so you can follow there if you would like. But interrupt me whenever you feel like you have a question or a request like this. All right, then let's go to our last decorator, which is a property. You are probably familiar with properties if you've used C# before. It works similarly. You can create a new property using this property decorator. And the advantage of using properties instead of using other like normal attributes is that you can define a setter and a deleter of these properties, and in the setter you can set certain requirements for the property. So in this case, you want to make sure that the given age is correct, and if the age was an integer number and it was between 0 and 150, then we actually set our property. But if not, then we won't set it. And let's go over this. So we create a person called John. John is by default 12 years old. And if we try to set his age to ABC, we would get a type error, but we say, no, thank you. We will just not set the attribute. And in the second line, you can see that the attribute did not change. You can set it like this, 85, that's a valid number. You can try to set it to 850, but that's not a valid value. So the setter won't do anything with the previous age, and you can delete the attribute or the property. Sorry.
Can you also try to set the age to a decimal number, or is this forbidden by the int keyword?
It won't be forbidden by the int. That's just a type hint. So if we would say make something like this. Oh, we should print it out. It's completely valid.
Okay, thanks.
These type hints are very useful for the developer, not so useful for the for Python itself. It won't really use it for anything except if you are developing in like PyCharm or Visual Studio Code. It will give you some warnings, if I'm correct. But I am not completely sure, so let's see. Self.n is n, and let's try to call this function from another function, being real creative with the names here, but at least you see an example where we call function inside a function, or like the inner method, and let's say, and you see that PyCharm warns you that the function 3 expected type int got float instead. But it won't raise any kind of errors or actual warnings.
Okay, thanks.
Thank you. All right. Let's go to reflections. You can access attributes in a different way, not just accessing it via instance. You can initialize something without a name and access its attribute using the getAttr function. It's a built-in function via the name of the attribute itself. And if you would try to access something that does not exist, then you would get an attribute error. But if you try to access it and it doesn't exist, you can say that you don't want to get an attribute error, you want to get some kind of default value back if it does not exist. And there you have it. Similarly, you can set attributes using the set attribute function. And you can have class A not have any kind of attributes at the beginning, but we can add an attribute with the name Apple and the value 15. And if you use set attribute, we can see that the attribute will be set, and it can be accessed using getAttribute, but it can be accessed using the normal or the usual method for it as well.
Excuse me, this will only be set in the object or in the class, also in the instance or in the class too?
It's only set on the instance.
Okay, thanks.
Maybe I should not go that fast because let's look at this line, for example. So we create an instance of A, And this function accepts the instance as a first parameter, the name of the attribute as the second parameter, and the value of the attribute as the third one. And looking at this specific syntax, you can guess that this function only sets the attribute on the instance level, because we only passed the instance to the function. And we have del attribute, which deletes an attribute from the namespace. So in the first instance, we initialize an instance of A, we print out the namespace of A, which should contain attribute 1 and attribute 2 with their respective values. And now we delete attribute 1, and we have a dictionary. So the namespace does not contain attribute 1 anymore. If we will try to delete it again, then we will get an attribute error, because the attribute 1 doesn't exist anymore already. And we can check if an attribute exists using has attribute. This is probably one of the most useful out of these reflections, because sometimes you want to see if a certain attribute has been defined previously or not, what's the value of it, and so on. For example, if you have attributes initialized inside of the init function, this can come in handy. You can also see this if in like if we would look at a.dict and attribute 1 in a.dict should be the same as has attribute for a attribute 1. But this is simpler. Okay.
Is there a way to check the values of the attributes?
Yes, you can check the values of the attributes using the get attribute function. In this instance, we initialize the new instance in the get attribute itself, but we can move it outside of that function. And oh yeah, I have overridden the A already.
But I mean, like, if we have like 10 or more attributes, and we would like to see, and all the values are like numbers from 0 to 10, and we would like to see if one of the attributes has the number 0, or I don't know, because with the method you showed us, we can check whether there is an attribute with a certain name. And my question would be if there's also a method to check whether some of the values is something that we are searching for.
I don't know if there is a built-in method to do that. You can obviously check it by iterating over the attributes themselves and checking the value for each of those. But I don't think there is a built-in method that would do that for you.
Okay, thank you.
Any other question, maybe in the chat? If not, then let's go to a shiny new thing in Python, which is a data class, which is also a decorator. Don't worry about this. We will talk about it tomorrow. So a data class defines certain functions for you already, like initialization, equals function, representation function, and you don't need to worry about any of those. You can just say that any instance of A should have a name, values, and a function. That's just like normal. And we can initialize it by passing the name of the class. So the first argument is the name, and the second argument should be the list of values. And under the hood, you will have an init function that takes names, the name and the values. And those are required positional arguments of the init function. We can turn these on and off. So if for some reason you don't want to have a default init function, then you can say that you don't want the data class to create one for you. And in that case, you cannot pass anything here in the initialization process, and you won't have a name for the instance because there is no name initialized in the instance.
Can you write an init function inside this data class then, or would you? Would it make sense?
Yes, you can write one. The advantage is that you don't have to. If you would only just initialize certain attributes in the init function, then you can skip that step. Sometimes you want to do more complex things in the initialization, and then maybe you don't want to use this.
Thanks.
Couple of other things that data class can define for you. So representation function. By default, it will generate a representation, and that representation will contain all of the attributes with their names in the representation. So when you print out the A instance, which has a pre-generated representation, it will be a pretty and informative representation. And if you set it to false, and you can define a representation function for yourself, obviously, but if you don't, then it will just print out the class information. The more interesting one is the equals. So in previous lectures, you've seen that equals can be between IDs or instances. You've seen that if a dictionary has the same key value pairs, even if they are in different order, they will be equal. And this is something that the data class can do under the hood. It converts the attributes of the instance into a frozen set, and with name and value pairs, and compares those two together. And if you created it with the default settings, you can see that if you initialize two instances the same or set the attributes the same, the equals function will handle it for you. So two instances will be the same if they have the same attributes. That's what I'm trying to say. And if you don't, then you can define an equals function for yourself. And we will talk about these operator overloading functions in a bit. Let's jump into inheritance then. So each class has can have a subclass, and we define inheritance in the in this format. Between the brackets, you define the class you want to inherit from, what the class is. Spoiler, there is multiple inheritance in Python. And if you check it with the isInstance function, if an inherited instance is an instance of the original class, not the subclass, you will get true, because it is an instance of the original one as well as the subclass. But float and int are not each other's subclasses. They come from the same root, but they are not the same. And every class by default inherits the object as their parent class. So every type in Python is an object, or at least inherited from an object. You can define a class using explicit inheritance from object, but you don't need to because it's the default. Every method is inherited in the subclasses, but you can override anything inside the subclass. So there is no, you don't need to specifically state that a certain method can be overridden by the subclass. It's the default state. And as you can see, the overridden function will override the parent class's function if you you create an instance of the subclass. similarly, if you have an init function, I will skip this and get back to it after this. So if you have an init function and you override it, you will need to call the super init function. So the parent class's init function, if you want to initialize the attributes that were defined in the super's init originally. That's what you can see here. So we have A as the object, and B overrides the init function, but it will call the initialization of A. And C also inherits from A, and it also calls the init function of A. These are both valid and do the same thing to call the super's init function. Also, you can access the parent other attributes and functions, even if you have overridden them. For example, if you want to define a new function that has been in the parent class as well, but you want to use the parent class's function somewhere in your new function, you can access it via super and dot and the function that you want to use. Okay, and this is a more complete example. An employee is a person, and an employee differs from the base person because it has a position and a salary, and you set the position and the salary in the init function of the employee, and you call the super function, pass the name and the age to that. That will set the name and the age for the person, and those can be accessible via the instance of the employee as well. All right, any questions about inheritance? All right, if not, then I think we should get a bit quicker because we are running out of time and we have a lot to talk about. So you probably heard this saying that if it looks like a duck, swims like a duck, quacks like a duck, it's probably a duck. And it's kind of true in programming as well. So we can expect that certain classes will be able to do certain things that have been defined by their base class. And as such, we expect that these two animals should have the make sound function implemented for them. And we can make sure that this is the case if we define a base class which has the make sound function, and by default it will raise a not implemented error because there are some animals that don't make a sound, but we expect that they override this function with their own interpretation of this function. it's kind of like an abstract class or abstract method in Java, I think. So we expect these to be overridden. If we would call the make sound function on a fox, which doesn't override anything from the base class, it will raise this not implemented error. All right. So similar to those special attributes, we have magic methods as well. One of these is the string method, which generates the string representation for an object, or at least it will be called when the print will try to convert the object into a string. And you can define it for yourself. If you don't do that, then you will get something like this is an instance of B or A. You've seen an example for this in data class where we did not override the representation function. And we can override these special magic functions as well. And operators are magic functions in and of themselves. You can actually look up the names of these magic functions for the operators, because it might not be that obvious, like the is equal operator. So the double equal is called eq. The greater than is GP. Adding is add. And you can easily look these up in the documentation, and you can override these. So there is a default understanding of equal defined by the object, but you should override it if you don't want it to be just a comparison if the IDs are the same. All right. So let's talk a bit about copying. You've seen in the previous lecture that if you copy a list using just the equal operation, then you can change the second list or the first one, either one, and the other one will change as well, because we didn't actually copy it, we just defined a new reference to the same memory address. And this is the case with the equal operator and the shallow copy defined in copy. So if you would say copy one and copy, so copy this previous list, and you do so, nothing changes, and it just points to a same memory address. So if you change one, you change the other as well. But if you use deep copy, it will create a new instance, and you can change the objects however you would like, and it won't affect the copied object. both of these can be overridden. So there are like these magic functions like bit equals and string conversion, and you can define which attributes to copy or deep copy in the new copied object. All right. As mentioned before, init is not the constructor of the object or the class, but new is, and new is a class method, and it's the first thing that is called when you create a new instance of an object, and only after this will be called the init function. New is for creating the memory address itself, and similarly to C++ and Java, there is a destructor or the delete function inside this inside the class, and it is supposedly responsible for deleting the class, but it's usually called by the garbage collection. And if you would run this, and you might interrupt this kernel, or I don't know, maybe you give a keyword what is that called? So when you stop the running of a Python code using your keyboard, maybe the garbage collector did not have any time to delete the object, so it will sit in the memory for a while if the delete is not called by the garbage collector. You can call the delete function explicitly. You don't need to rely on garbage collection, but it's not the best practice, or at least it's not usually used.
Maybe one question: when should I put something into the init, and when put it into new? So because for me it seems we only change the init definition.
Yes, usually we only change the init definition, and that's because that's where we initialize the attributes and maybe initialize some other thing inside the function. We don't usually do anything extraordinary with new. Usually you don't need to overwrite it at all. There are very rare occasions when you want to subclass something very specific and it needs you to have some very specific things set in new, but that's usually not the case, and you don't need to worry about it in 99% of the cases.
Okay, thanks.
All right, maybe we will be able to finish this. So every object has full access to its insights. So every object has full introspection. You can check each function and attribute of a given instance. And using dir, the dir function, you can list those out. Compared to dict, you won't see the values of certain attributes, but you will see each and every single one of the accessible functions and attributes, or at least every accessible attribute in a given instance. This is just saying the code attribute contains even more information about the accessible functions in the object. And yeah, you can actually get the source code of function using this inspector get source lines. So if for some reason you wouldn't have access to the code other ways, you can get it using this. All right. We still have multiple inheritance to cover, and then we will move on to exception handling. So in contrast to Java, there is multiple inheritance in Python. And that means that we can inherit from however many parent classes we would like. And the order of inheritance is usually defined by the order of the parents between the brackets in the definition of the class. So if A and B have a method with the same name, A's method will be the inherited one by default. You can, well, not change it, but you can explicitly call B's init if you would like inside this init function. But by default, the first class is the first one to get the methods and attributes from. But you can access both. All right. Any question about any object-oriented things that we ran over?
Yeah, so if you have multiple parents, then and you want to specify one of these methods, so you still have to call super for all of them, or
you don't need to call super if you don't need the parents definition of a certain method or attribute, but you can call it if you want to access explicitly the parents definition.
and
So-
if you just want to init the parents, if you call super init in your init function, so if you just want to initialize them with this super, all of them are initialized. So would I have to give a parameter list with all the parameters they need, or?
With this super, you will only call the A super. But if you would like to call b init. Oh, shoot, we need stuff there, I think. Yeah. So you can explicitly call the other parents init function as well, but super will be the first parent.
Okay, thank you.
All right. Then we still have about 10 minutes to cover exception handling. So previously, you've seen a bunch of possible errors raised. And for example, this one will raise a zero division error because we try to divide by zero. That's obviously not a good thing. And if we don't want to have our code interrupted, we can try to put these in a try except block. Try inside try, you can put anything that may raise an error, and in except, you can specify the exceptions that you want to catch. And in this case, we have zero division error. And if you say that except zero division as E, you can actually catch the object and access the inner state of the zero division error object. And you can write out the original exception or the type of the exception, anything. And this way, it won't kill your process. There is an additional block that you can add to try except, which is finally. And finally will definitely run even if you got an exception during the try and except phase. So as you see, now we raise back the error that we called. You can raise an exception using the raise keyword. So we raise zero division back, but finally runs before this raise can run. And we can use this finally block to clean up, free up memory or similar things. If you would write a function that returns something in the try block, and you have a finally, and the finally also has a return block, the return in finally block will be the actually returned value. So please be mindful of that. We can also try to capture multiple exceptions if we have code like this. So in this, we try to access something that is not in the list, that's index error. And after that, we try to divide it by zero. That's a zero division error. And this except block would catch either of those. So if I would correct this to be like this, we get the zero division error instead of the index error. And you don't need to be very specific with your exceptions. every error, or most errors, come from the exception class. And if you say except exception as E, you catch every kind of exception with this statement. And you can actually leave it completely empty as well. And in this case, you also catch every kind of exception, even those that are not subclasses of exception. There is very few of those. And usually you will come across index errors, attributes errors, and so on. And those are all subclasses of exception. So the raise keyword is responsible to raise an exception. And in this instance, we raise the value error inside the try block and we catch it in the except. If we would to change it to only catch index errors, this would be raised. So you need to cover your ground when you are using the except block. And you can also provide a custom error message in the error when you are raising it. So you might want to specify it for the developer that the value error was caused because some kind of value should be between some other values, and this is very useful for debugging. You can also chain exceptions. Where you raise some kind of error in the try block. You don't need to explicitly raise it. You could just have like a 0 division here. And in the except block, you try to catch it and you quote it. And because you quote it, you raise a different error with a different error message. But for the user, user will see both of these exceptions or these errors with all of the error messages that you provided. So it's easier to go back and trace back where the exceptions should be handled or how to change their code to be able to handle the exception. And someone asked before if there is a multi-line comment in Python, and no, there isn't, but the multi-line string covers for that kind of. So this way, this is just a string. It won't do anything in your code. All right, assertion is a different keyword, but that's also an instant or a subclass of exception. It works like this. You have the assert keyword that checks if this value is true. And if it's true, it won't do anything. But if it's false, then it will raise an assertion error. And you can also provide an error message to go with that. We check your assignments using these assertions. So it's good that you know what to be prepared for. All right, warnings. So if you don't want to interrupt the running of your code with an exception, but you want to warn the user that something is like deprecated, you shouldn't use this method because there is a different method that does the same and is more efficient, you could use warning to do so. And this will print out that runtime warning has occurred, but you don't need to worry about it. Similarly to exceptions, you can give an error message or a warning message when you are raising this. Don't raise warning with the raise keyword, because raise will create an error. So instead use the warnings library and warnings.warn, and that will just create this lovely message for you. You don't need to initialize a warning type thing. You can just pass a warning message, and that will be by default a user warning type of warning. And if you would try to warn about an error, that will be a type error, because warnings only supports instances of the warning class. So you can also define your own exceptions and warnings. You need to subclass the warning class to have your own warnings. You cannot try to get away with subclassing the exception, because that will raise a type error when you try to warn people. And you can subclass the exception as well, and then you can raise your own exception. You can define default string that you print out for the new exception that you defined. But before you try to define your own exceptions, I would recommend that you take a look at the available exceptions in the documentation of Python, and make sure that you don't try to reinvent the wheel, so to speak. So it's not that common that you need to define your own exception class. Any questions? Anything?
There's a question in the chat whether can you catch warnings like exceptions?
You cannot. Because they are not like errors, I think. Let's try, because I have never done that before. Let's see. Except warning, because it has to be a subclass of that, and print warning, and you cannot. If you would want to do something like that, you should. I mean, you shouldn't, because these are warnings and you should not raise them. But if you would raise it and say except warning. Then you can catch it.
But wouldn't you then kind of so why would you write a warning if you catch it? Then you would use an exception, right?
Exactly. That's why I wasn't sure about it, because it doesn't really make sense to catch a warning. A warning won't stop the running of your code. It will just print into the standard error output that there is a warning. If you want to, for some reason, catch this, the warning has to be raised and quoted that way, but don't do that.
But is the warning class a child class of exceptions?
They have the same base class, exceptions and warnings, but they are not the subclass of each other, I think.
Because my question would be if we can raise like anything, because if we can raise a warning, can we also raise a class we've wrote ourselves?
No. They have to be a specific base class. And sorry, no, it's not there. Somewhere in the documentation you can actually see the there it is. Oh no, sorry. Warnings are the subclass of exceptions. I'm so sorry. And they are derived from the base exception. So I think base exception is the basis of this topic.
Okay, thank you.
Sorry, I didn't hear you.
I just said, okay, thank you.
Oh, sorry. All right. I think I will stop screen sharing and also the record.